In this video, we're going to talk about HTML and the rvest package. Oftentimes, the information that you want from the internet is actually embedded into some web page, so you can't just download it as a CSV file or something like that. Making GET requests with httr will get you about 80% of the way to where you want to be, but there's still a lot of the web page that you actually want to pull out. So it's not just about downloading the web page itself, it's about kind of parsing the web page and really extracting the data that's in it. To do that, you could use Stringer, but that's a really heavy burden, and worse, web documents are really highly structured documents. They have to be readable by the web browser itself. So they should be able to be parsed in some way that's systematic, as opposed to you going through and making a whole bunch of, str extract alls. And that's really the purpose of rvest. Rvest is really mainly used for scraping and extracting data from HTML documents. It has some other features that I'll talk about at the end, but generally that's its purpose, to process web pages that are served over HTTP. So it's going to use httr to actually obtain those HTML files, and then it's going to process them itself using essentially a bunch of string processing. To understand how this works, we really need to talk about HTML. HTML, the hypertext markup language, is really the standard language for web content. It's a markup language, so its textual annotations are going to be distinct from the text itself, and you should think about HTML just like LaTeX. The difference is, instead of making PDFs, it's going to make web pages. So whereas the LaTeX compiler would convert a .tex document to a .pdf, the web browser is going to convert a .html document into the visual web page that you actually see. Okay, it does a lot of other things, but that's the main kind of point on the front end. On the back end, the web browser is making those HTTP queries. Nowadays, browsers are very, very flexible tools, so they can do all sorts of things, but that's going to be their basic functionality. We should say at the very beginning that markdown.md files are converted to HTML as just kind of a simple way to create HTML code if you're unfamiliar with the HTML language. There isn't really an analog here with LaTeX. However, we know that markdown files can also be converted to other types of files like PDFs or tex files or even Microsoft Word files using the pandoc command line utility. And that's what's used, for example, in R Markdown. In everyday use, web browsers query web servers for the HTML documents. The documents that they get back are going to be .html files, along with things like images and videos and connections so that they can stream those and so on. The HTML files make references to the images, just like in LaTeX, and they also embed code in other languages, most importantly JavaScript, to enable better interactivity. So HTML itself does support interactivity, like when you mouse over a link or whatever, but it doesn't support a lot of other advanced interactive features. Almost all of that is actually scripted in the JavaScript language and interpreted and executed by the browser itself. So here's a basic HTML file. Notice that the file extension is .html. The first line is saying that, hey, this is an HTML file. Usually you would also see version numbers in there and so on. And then you're getting HTML, head, body, and then it closes. The web page that this would create would look like this in Chrome. Notice the structure of the web page. Again, you have environments, or what would be environments in LaTeX, open and close, open and close, open and close, open, close, open, close. Those are called tags in HTML. The tags open and close, just like LaTeX. There are some exceptions to that that are actually fairly common, but in general, in terms of tags in general, that's rare. They usually open and close. Now, you can see actually just from the HTML what it's creating or how it is rendered as part of the web page itself. So this thing that's in the so-called P tag is being actually displayed on the screen, and the thing that's up here in title, which is nested in the head tag, is actually part of the tab itself. So it's not part of the kind of textual or body part of the web page, it's something else. And that's a typical feature of everything that's kind of in head, okay? Head data is metadata that is actually not displayed, okay? The only exception to that I can actually think of is the title itself, which is, this is a title, okay? Stuff in the body is actually displayed, so this is very, very similar to LaTeX, right? Stuff before begin document is not displayed, stuff after it is displayed. Here, stuff before body is not displayed, that's in the head tag, and stuff included in the body, that is displayed. Most browsers have the option to view the HTML used to generate the web page. That's called the page source. In Chrome, go to View Developer View Source. In Firefox, Tools Web Developer Page Source. And in Safari, you actually have to enable this. So Safari Preferences Advanced Show Develop menu in the menu bar. and then just go to the new develop menu and show page source that way. This is usually a useful feature to do, and there's some interactivity where you can click on the web page itself and you'll see that part of the source and vice versa. So web browsers are very helpful in viewing the source. I'm not sure what the analog is in Edge, but it's going to be very similar. When you view the source in Chrome, it looks like this. So notice that the URL looks a little bit different, view source, and then you're actually just seeing the source code below. And conveniently, you get the syntax highlighting, so that's pretty nice. Putting these things side by side, you'll get something like this. Usually source code is very difficult to read. You can get a general sense of what's going on in the sense that you still have syntax highlighting and so on. But this code was really meant to be sent over the internet. In general, web developers will either have a hierarchy of code, so this code is being kind of automatically generated, or they may be doing something called minifying, which is trying to shrink the code as much as possible so that they can send as little information over the internet as possible. That makes it very difficult on the back end to actually read that source, even though your computer can read it just fine. So obviously there are also going to be some security concerns, and it's going to be harder for you if you're a person who's trying to scrape information from that web page. Nevertheless, you should be kind of thinking of these as the two dual views of web pages. There's the thing that it actually gets rendered into, and then there's the page source itself. Obviously, you're generally looking at the thing that it gets rendered into, but when you're doing the extraction part, you need to know something about the source. There's actually not very much you need to know about HTML, about the tags themselves. Obviously, it can get very complicated, but we're not looking to be web developers. We're looking to learn things about how we can extract information and data from web pages. And to do that, we don't need to know much about HTML itself, but we do need to know some of the general features. So the tags that we're going to want to know are the so-called H tags. It's H followed by a number, like in this case H1. These are header tags, and the rough equivalent in LaTeX is section. So section, subsection, subsection, and so on. We'll see examples of this in just a moment, but these are going to demarcate sections. Next, we have the so-called P tag. That's the paragraph tag. That's usually where normal text is embedded into web pages for things like news articles or Medium or something like that. A is a hyperlink tag. This is actually going to enable hypertext for the World Wide Web. So this is directing you to a different web resource by some kind of interactivity, which is usually something like clicking. So again, A tag and then the hyper reference to where the link actually goes to, and you can actually just put a URL in there and it will resolve just fine. Something that's less common these days, just because it looks a little strange on web pages, but it's still very useful for us as statisticians and data scientists, is the table tag. So if people want to embed information, if they want to embed data into a web page, they're usually going to do this with a table tag, usually marked up as something a little bit different. Now, Wikipedia does this, for example, all the time. And if you want to extract that data, it's going to be embedded in a table tag. We'll come back to that in just a little bit. Lastly, I thought it'd be useful to put an example of a tag that actually is self-closing. This is the so-called horizontal rule tag, and it will actually just make a horizontal line across the screen. You've seen these all the time. You've probably just never thought about it. So here's an example of these different tags in action. We have all of the header tags followed by a P tag and followed by a hyperlink right there at the bottom. Now, these will be rendered with fonts and sizes that are defaulted by the browser. So different browsers may render these at a basic level differently. For example, I never said use the font Times New Roman. Aspects like that, very much like in ggplot2, are going to be defaulted by the browser. And they're going to be reverted to when a web developer uses some feature, usually something like a font, that the end user doesn't have on their machine. Now, HTML tags, much like lists and objects in R, can be given attributes that are understood to be metadata that tells you a little bit more about the object. They look like this in a P tag. So we have the P, that's actually saying what kind of tag it is, followed by attributes and values. Attributes and values. So these are key value pairs that come after whatever the element tag is. Like in R, the class attribute is commonly used to communicate the object type. That would be like an S3 class object in R. In HTML is just a class type, but there's a hierarchy of these. So for example, the ID attribute is the exact same kind of attribute. It's just more specific to the object. So it's going to give preferential treatment because it's more specific. With these attributes, you can actually style the content that is embedded within that particular tag. For example, here's a different file that actually just says hello Venus, hello Earth, hello Mars in terms of HTML. Notice that they're specified simply as 3 different P tags. If we wanted to start styling this HTML file, we could put style attributes in the P tag itself. So this, for example, is how we would colorize each of those different pieces of text. Now you may say, well, we were just talking about class attributes and IDs, but that's not what's being referenced here. Here we're just colorizing text. Where do those class and ID attributes come in? And those come in through something called CSS, or cascading style sheets. These enable developers to simultaneously style a whole bunch of tags of a given type. So let's say every time you have a paragraph tag, you want to colorize your text in a particular way. That would be enabled by CSS. Usually CSS is actually contained in other files with the file extension .css, and then it's imported in the header of the HTML file. That's not always how things happen, but it is very typical. Now, the way that CSS targets particular elements of the web page is through something called selectors. So for example, how do you say that all p tags are green or something like that? You do that through selectors. And the most basic selector out there is the element selector, which is actually the tag itself. For example, with p tags in the example that I just mentioned, if we wanted to change the font to the Georgia font and the color to green, we would do this actually up in the header under the style tag label, which is going to manipulate the behavior of any p tag that actually shows up in the body. It's a very simple idea, but it's also very effective. Now that's the element selector. If we want to be more specific, we could use class selectors. Those are going to target class attributes. For example, here, I go down and I name two of those p tags as being of class foo, and then up here in the style, I say everything that is of class foo, and that's actually demarcated with .foo, is going to be colorized brown. Notice that when it's actually rendered over here, the brown takes precedence over the green because the class attribute is more specific than the element attribute. That is the p tag itself. The next specific is ID selectors. These are going to target ID attributes, and they're demarcated with this hashtag. So here I've gone into this p tag at the bottom, the middle one, Hello Earth, and I've said this is of ID bar. And up here in the style attribute, I say everything that is of ID bar, you should change its font size to be 150% of usual. When it's rendered, of course, it's a lot larger than it usually is. So we're kind of thinking of a hierarchy of types here. So we have element tags, we have class tags, and then we have ID tags. Those are going to be the highest on the hierarchy or the most specific. This is actually not exactly how it works, but it's kind of good enough for a lot of the stuff that we're going to do. As I said before, usually the HTML and CSS files are actually split into two different files. This is very much like macros in LaTeX, where you may have a macros file that you carry around to many different projects, and in a text file, you just import that file. Here, you have the CSS file. The CSS file is going to be distinct, and then it's actually loaded in the HTML file. Actually, the way that most web developers will do this is that the CSS file is itself a resource that is hosted on the internet. So if you look at the source of most web pages, the beginning in the header is actually going to refer to cascading style sheets that are themselves somewhere that need to be resolved on the internet, usually under the same domain as the developer of the web page. Then they'll use it on many different web pages. That way they can ensure a unique and consistent style across many of their different web pages, and it gives a nicer feel to the web page itself. Now that we know a little bit about HTML, it's time to talk about rvest. In rvest, the standard workflow consists generally of 3 steps. The first step is going to use read_HTML to actually go out and get a web page and then parse it into what is an XML document object in the R language. XML is the extensible markup language. It's very similar to HTML in the sense that it's a markup language, it has tags and so on, but it is actually somewhat distinct. How it's distinct doesn't really matter to us. What does matter, or what may matter, is that there's a specific way to refer to particular tags in XML, and that's through a specification language called XPath. We generally won't need to do this, so you can almost totally forget it at this point, but it will come up in just a little bit in Selector Gadget. The second step that we're usually going to do is use HTML nodes to filter out the desired content that we want. As I said before, usually web page sources, if you just look at them, are very complicated, and it's just cognitively difficult to actually tease through everything that you're looking at. But computers are very good at doing this. And the way that rvest is going to do it is through something called HTML nodes. It's going to allow us to go in and extract pieces of the web page because it understands the structure of the web page itself. This is usually done by referencing the CSS tags, but it can also be done through XPath. As I said before, looking through a page source can be helpful here, but usually is not because it's just a morass of text. Selector Gadget is what is typically used, and we'll see that below. rvest also provides some functions to help you do this. Those functions are HTML name, HTML attributes, and HTML children. These will help you understand the tree structure of the HTML markup language. When you've isolated the part of the web page that you want with HTML nodes, it's time to parse that part of the web page. To do that, you'll typically use either HTML text or HTML table, just depending on which of those you're actually interested in doing. Let's see some examples. Again, the first step is going to be to use read_HTML to get a web page and parse it into an XML document. Here I'm going to use that planet's web page. So you see me parsing it in, and you can actually see that it says it's an HTML document, and it gives us 2 lines of that file that refer to the header and to the body of that document. In this case, you can actually identify pieces of that HTML file that we wrote. If you want a different web page, of course, you just enter it instead of planets-6.html. The class of the object is an XML document, XML node, and you can look at the methods right there or look them up yourself. HTML or XML structure will give you a nice readout of the file itself. This is similar, but it's a little bit more readable than the page source, and it includes selector info. However, in practice, it usually spams you because even the web page at this level is just too cumbersome to actually view the whole thing. You can convert it to a list with as_list, and that can be useful if you want to parse this kind of per style, but in general, that's also not super helpful until you're somewhere further down the chain. The real strategy that you should use here is to use HTML nodes to filter out only the desired pieces of the page that you want, which are usually identified by CSS. You can think about this as zooming in on part of the web page by using a selector. For example, with planets XML, I can say HTML nodes P, and it will extract all of the P tags that are in that HTML document. Or I could pull out .foo, that's all of the class foo, or I can pull out #bar, that'll give me all the ID bar. So that's the reason why we were really interested in the CSS selectors before, was so that we know the language and have the ability to extract pieces of the web page. Once we extract them, then we use something like HTML text to actually just convert this thing into text. If I use this on the whole web page, of course, I just get all of the textual content of the web page. That's either the title of the page or it's something in the body that's demarcated by a p tag. And of course, this is a little bit more legible if you actually use cat on it. Once you extract the text, that strips away all of the HTML tags. Notice that you don't see any p tags or anything like that in there. So from there, you can just use stringer to do string processing as usual. So you're not totally done, but it gets you to a good position to actually start whatever you're actually interested in the web page. And of course, that's something that rvest can't actually bake into itself anyway. Tables are the alternative here. The table tag, of course, is used to format tables in HTML. It's often used to display data on a web page, and it contains 3 kinds of children tags. There's the tr tag, that's the tag for rows of the table. These tables are going to be entered by row. The th tag, that's going to be used to enter column headers, and then the td tag, that's for individual elements in the table. So a table would look something like this. We have the table, you see I'm using an ID tag calling it my table. We have 1, 2, 3 rows of the table. The first row has headers, and the second one and third ones have just ordinary elements with TD tags. Notice that the header row, of course, is shown up as bold, and then other rows are just undistinguished, normal text. How do you parse these? Notice these are in a file called table.html. So I'm going to start by using read_HTML. That's how we're going to start with all of our HTML files. It's going to read it in as the HTML document that we know is actually an XML document. We could just use HTML table directly on it. If the web page you're looking at has a lot of tables, you're going to get a lot of stuff back there, and so you're going to have to comb through it on that side. That may be a useful thing, or it may be hard. The alternative, of course, is to kind of narrow it down by HTML nodes to find the particular node that you want. So, just depending on how you're feeling about the ability to pull stuff out using CSS selectors, you may or may not want to just use HTML table directly. Certainly the kind of more approved way of doing this is going to be just using HTML nodes and then using HTML table. But those will extract the tables as list elements, and then you'll usually just extract them directly from the list. Selector Gadget is really the saving grace for CSS selectors. So occasionally you can actually just look at the source of a web page, and you can tell which CSS tag you need to refer to the object that you want. But I will say that is rare, and they usually have very arcane names attached to them. So instead of looking at the source itself, there's a tool that's created to help you select parts of the web page called Selector Gadget. It's written in JavaScript, and it's an interactive GUI style tool that will help you select elements of the page. As I said, it's written in JavaScript, and you use your mouse to kind of highlight and select parts of the pages that you're interested in. It will try to extrapolate from those, and then you'll deselect the ones that you're not actually interested in. So again, select what you want, deselect what you don't want, and then copy and paste the selector into HTML nodes. Here's an example. If I use Selector Gadget on this Planets 5 page, in this case I clicked Hello Earth here, and you see how it's been highlighted in green with the tag kind of here, body P. That's the element that it's actually a part of. It selected that part of the page. No other part of the page was actually shown here, so I don't need to deselect anything, and then the selector actually just shows up down there. So it tells me exactly the selector that I need to extract just that part. In places where things go bad, you'll see an example of this in just a minute, you'll see a whole bunch of yellow stuff, and you'll deselect it by clicking the yellow things to say, no, that's not part of what I want. They'll show up in red, and the things, of course, that you originally clicked, those will remain clicked. Okay? So let's see how this works for our email scraping example. This was one of our first examples using just pure read lines and stringer. When we used httr, we were able to pull the web page down in kind of a cleaner way, pull out the content with text, and then use string processing. If we want to use rvest, we need to actually use Selector Gadget to figure out what the CSS selectors are that we want. Okay, so I navigated to the web page. I first clicked right here. Okay, like that is one of the web pages that I want. And ideally, it would go all the way down the page and it would select every one of those because hopefully they're in the same kind of tag. Okay. What actually happened, notice, by the way, that it selected this email address. Anything that it selects is in yellow. Okay. And that's fine. If it selects things that you don't want in yellow, you'll click them and it will deselect them and that will show up as red. So here, notice my mouse is right here. I clicked that, it deselected not only that, but it deselected other things that you might not have expected, okay, like these things over here. And if we scroll down the page, which of course we would always want to do, we're doing this interactively, we would want to make sure that every one that we wanted was highlighted in green or yellow, and there's nothing else highlighted that we want. Okay. Once we're satisfied with that, we pull the selector from down here. Notice how strange that is. .faculty directory -item underscore. This is not something that you would have guessed. And if you're just trying to wade through the HTML itself, it's probably hard to find that. Okay. Now, I can combine these together. So I pull the web page with read HTML. I use HTML nodes to filter down to just those nodes that I'm interested in that contain the web pages. And then I just directly pull the text out. If there was something else that I wanted, of course, I can use stringer to process that text because it's just a simple character vector. Now, rvest can actually go quite a bit further than what I've described here, although this actually covers a lot of the cases. rvest has the ability to navigate the web as a so-called headless browser. So when we usually use a web browser when we're just on the internet, we're visualizing everything, right? And of course, as we're doing this in a natural way, we're clicking on buttons and we're actually interacting with the web page. Well, it's helpful to have a framework in which we do that in an automated way. In some cases, you'll actually go to web pages and you will actually have to interact with the web page to some extent to get the data that you want, or to get all of the data that you want. In those cases, you really need to have more than just the simple kinds of queries that we've seen so far. You really need to have something more like a headless browser. These will allow you to kind of click through and navigate through web pages as if you are actually sitting there clicking things. Okay? We won't discuss this in this video, but I will recommend places that you go and things to look into if you're interested in that. To crawl through web pages, these are useful functions to you. HTML session, all of these are in rvest. HTML session will create a session, jump to, follow link, forward and backwards. Those are going to allow you to navigate kind of in and out of web pages as if you're sitting at a screen and you're actually doing this yourself. To fill forms out, for example, sometimes it's nice to have an automated way to enter in text into a form, or to set specific values. Maybe you're setting date on a web form, or you're needing to click something, or you're submitting a query in Google or something like that. For those, you actually have to have the ability to act on a web page. And this is of the form submitting form back to an HTML session. So look into those if you're interested in headless browsers. There's just a tremendous amount of stuff that you can learn and do that's fascinating, and you can get some great information off of the internet if you just hone these skills a bit.